So we have already discussed about electrostatics first chapter, and now we will start another new chapter from modern physics, that is atom. First we have to know what is atom. Atom is the fundamental piece of the matter which takes part in the chemical reaction. That means every matter consists of atom. No doubt there is other smallest particles inside the atom, but for the matter, atom is the smallest particle which can take part in the chemical reaction. After the discovery of the atom, different models assumed by different scientists, and among them some basic models given by Thompson, Rutherford and Bohr we have to discuss here. First we have to know what is model of atom. Model of atom is nothing but an explanation regarding the structure of the atom is called the atomic model, model of atom. An explanation regarding the structure of the atom is called the model of the atom, or we can say atom model. Now we have to discuss Thompson's atom model. Thompson was the first person who gave an idea regarding the structure of the atom, and according to this model, the whole of the positive charge is distributed uniformly of a sphere, and all the negatively charged electrons are arranged within the sphere here and there. That you just see this figure, positively charges are just uniformly distributed just like clouds, and negative charges are there inside. And this model is popularly known as Plum pudding model. Why this is known as Plum pudding model? Just you have see the watermelon. Inside the watermelon, you just assume this red part is the positively charged, and the seeds which are blackening in color just considered as negatively charged particle. So we can say also this is the watermelon model, means comparing with the structure of the watermelon. And inside there positively charges are there and negatively charges are just distributed here and there. Every electron is attracted towards the center of uniformly charged sphere while they exert a force of repulsion upon each other, because I have already told that same charges repel each other and opposite charges attract each other. And here since negatively charged electrons are there, so every electron is just attracted towards the center of uniformly charged sphere while they exert a force of repulsion upon each other. No doubt Thompson gave a better idea, but there are some limitations. Means drawbacks. What are the failure of this model? Though he gave some assumptions or postulates regarding the structure of the atom, but still then the model has some limitations or drawbacks. The first limitation is that the model concluded that hydrogen can give rise to a single spectral line, but experimentally hydrogen is found to give several series, and each series consisting of several lines. That means according to this model, the hydrogen has continuous line spectrum, but experimentally it is found that the hydrogen gives line spectrum. So this model is need to be modified, and this model is discarded after Thompson most probably 1987 discussed about this model. After that in 1913 Rutherford come to give an idea about the structure of the atom. For that, Rutherford had done an famous experiment, that is Rutherford alpha particle scattering experiment, and from the conclusion of this experiment he gave some idea regarding the structure of the atom. The experimental set-offs are as follows. There is a source of alpha particle, and at some distance there is a thin gold foil. Around the thin gold foil there is a detector. Detector is made up of zinc sulfide. This detector is a fluorescent screen, circular fluorescent screen. When the scattered particles are there, it can be easily visible, and when it can easily enter, and when from the source of the alpha particle is nothing but the positively helium charge, helium 24, and when the alpha particles they took a thin gold foil. That gold foil I have shown you in that figure. Approximately this thin gold foil, very thin, the thickness is approximately 2.1 into 10 to the power minus 7 meter, and placed it in the center of the rotatable detector. That detector, yellow color, that detector made up of zinc sulfide and a microscope. Then they directed a beam of 5.5 MeV energy alpha particles emitted from a radioactive source at the foil, and this one the source of the alpha particle having energy 5 MeV approximately, and from that source a beam of particles is just emitted and fall on the thin gold foil. And Rutherford was interested in knowing how the electrons are arranged within an atom. That means Rutherford designed an experiment for this also. And in this experiment, that backside the experimental set-off is there, and in this experiment fast moving alpha particles were made to fall on a thin gold foil. He selected a gold foil because he wanted as a thin layer as possible, and this gold foil was about 1000 atoms thick. And I have already told that alpha particles are doubly charged helium ions. What he observed, that most of the fast moving alpha particles pass straight through the gold foil. That means there is some empty space. That conclusion we will discuss later. And some of the alpha particles were deflected by the foil by small angles, and approximately 1 out of every 12,000 alpha particles appears to rebound. So what he conclude from this model? He conclude that most of the space inside the atom, because if empty space is there, since empty space is there, most of the alpha particles pass through the gold foil without getting deflected. And next conclusion, that very few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space. That means when it passed through the center approximately, it will just deflected back. It will know from that there is some hard substance is there, that is nothing but the whole of the positive charges. Approximately we can say the mass of whole of the atom is concentrated at that point, which is later known as the nucleus. So we can easily say that Rutherford discovered the nucleus, and a very small fraction of alpha particles were deflected by large angle, indicating that all the positive charges and mass of the gold foil are concentrated in a very small volume within the atom, and that is known as the nucleus. He also calculated from the data that the radius of the nucleus is about 10 to the power 5 times less than the radius of the atom. So these are the conclusion. And from that experiment, two basic terms we have to know. One is distance of closest approach and another is impact parameter. What is distance of closest approach? When the alpha particles comes, the distance of the closest approach is the distance between the nucleus and the alpha particles when it has come to rest, or all of its kinetic energy is converted to potential energy. When it will come to rest, ultimately the kinetic energy converted to potential energy. So and the impact parameter is nothing but the perpendicular distance between the path of the projectile from the center of the nucleus. By figure I will show you how. You just see that when the alpha particle will come, it just deviated from the nucleus, and if we measure the distance, this distance, we can get this is the minimum distance. So that R minimum is the distance of the closest approach, and from when the alpha particle is just moving from the line of the nucleus, the perpendicular distance that is represented as B, that is known as the impact parameter. Mathematically we can calculate the value of that impact parameter, the expression for that impact parameter, but there is no need. You have to know only the basic ideas. Then from this experiment, Rutherford gave some postulate about the model of the atom, and Rutherford able to modify the drawbacks of the or the limitations of the Thompson model of atom, and he gave some ideas which treated as Rutherford's postulates of atom. The first postulate given by him, that an atom consists of equal amount of positive and negative charge, so that the atom as a whole is electrically neutral. Since positive and negative are just same, so it must be neutral, the atom must be neutral. The whole of the positive charge of the atom and practically whole of its mass is concentrated in a small region which is called the nucleus. That means at the center of the atom, the nucleus is there, which is whole of the positive mass, positive charges concentrated, and the size of the nucleus comparative to the size of the atom is very small, and the negative charges called the electrons are distributed all around the nucleus but separated from it. From the nucleus, the electrons are present at a certain separation distance, but they are distributed all around it. And for the stability of the electron at a certain distance from the nucleus, Rutherford proposed that the electrons revolve around the nucleus in circular orbits. So how electron will exist? Electron just revolving around the nucleus in a circular orbit, but there is no fixed orbit. Ultimately they are just revolving. This electrostatic force of attraction between the nucleus and the electron provides the centripetal force, and the nuclear diameter is approximately 10 to the power minus 14 meter. You can see here the Rutherford model, how for an carbon atom the nucleus is there. That means that red mark shows the whole of the atomic nucleus, and the electron is revolving, but there is no fixed orbit. Maybe, however, it may be rotate around the atomic nucleus, and that is the basic drawbacks comes in Rutherford model. So what are the limitations or drawbacks we have to now discuss? First thing is the instability of the atom. According to electromagnetic theory, when electron just revolving around the nucleus, it will radiate energy, and when that means it moves through the centripetal acceleration in the spiral path you have seen here, so it radiate energy continuously. Since it radiate energy continuously, So the energy will gradually decrease, and following a spiral path, the electron ultimately fall into the nucleus. That the whole of the structure of the atom will collapse. How it will exist? So that is the first limitation, that instability of the atom. Atom will not stable according to his idea. And second limitations about the hydrogen spectrum. Experimentally it is found that hydrogen spectrum has line spectrum, different series spectrum are there, but according to Rutherford model, electrons can revolve in any orbit, so it emit continuous radiations of all frequency, but practically atoms emit spectral lines of only definite frequency. So that is the next drawback regarding the hydrogen atom. You have to remember that two limitations of that Rutherford model, and since these drawbacks are there, this Rutherford model is also need to be modified. Then the famous scientist Niels Bohr will come and give the idea regarding the structure of the atom, and he gave some assumptions that are known as the Bose Postulates. And Bohr just say some ideas similar to Rutherford, but another some parts he just modified. First postulate he just gave that the central part of the atom is called nucleus, which is same as that of Rutherford, which contain whole of the positive charge, and almost all the electrons revolve around the nucleus in fixed circular orbit. He just modified that the electrons are revolving around the nucleus in fixed circular orbit, not however the path means here and there it is not moving. And second postulate is that these fixed circular orbits are called stationary orbits or permitted orbits. In such orbits, electrons do not radiate energy. So that is the failure can be clarified by this stationary orbit or the fixed orbit. When the electron is in the stationary orbit, it will not radiate energy. So instability will not occur. And next thing, which is very important property, that when revolving in this permitted orbit, an electron possesses angular momentum, which is an integral multiple of Planck's constant h by 2 pi. Angular momentum you have already known in 11th class, that angular momentum is nothing but m omega or mvr. This angular momentum is n L equal to n h by 2 pi, where n is an integer and h is the Planck's constant. And when the electrons are in the fixed orbit, I have told it will not radiate energy. But when electron jumps from higher to lower orbit, or it will goes off from lower to higher orbit, what will happen? It will radiate energy, and the radiation energy will come in terms of the frequency and in this type of the equation. Suppose the energy possessed by the second orbit is E2 and the energy possessed by the second orbit is E1. Then when an electron absorb energy, they move to a higher orbit, and when they emit energy, they just comes to the lower orbit. And suppose electron is jumping from higher to lower orbit, means E2 having energy E2, second orbit it will having energy E2, and in the first orbit the energy is E1. Suppose it jumps from second to first orbit, and nu is the frequency of the radiant energy, then the amount of the energy releasing energy becomes h nu equal to E2 minus E1. This is the equation, and all the laws of the mechanics can be applied to revolving electron in a stable orbit in that permitted orbit, while they are not applicable to an electron in transitions. Mechanical law, the laws we have discussed in mechanics, we can apply only in the stable orbit, but not for the transition. That means when it will move from upper to lower, or when it will go from lower to higher, this law will not applicable. And this is all about the three models of atom. Next we will discuss about